April 13, 1945. Shima Airfield, Ryukyu Islands. Lieutenant Colonel Lewis Sanders stood beside a P-47 Newton's Thunderbolt, watching his ground crew attach the fourth and final drop tank to the fighter's hardpoints. The aircraft squatted heavily on its landing gear, weighted down by 1,266 gallons of high-octane aviation fuel. Around him, 53 more Thunderbolts of the 318th Fighter Group prepared for a mission that Japanese intelligence had calculated to be impossible. The briefing had been clear: Tokyo, 840 miles to the north. The target was not merely symbolic. American planners needed fighter coverage over the Japanese capital, needed to prove that no corner of the home islands remained beyond reach. But the mission presented a problem that had vexed Allied air commanders since the first B-29 raids began striking Japan from distant island bases. The distance from Shima to Tokyo and back exceeded 1,600 miles. Earlier P-47 variants lacked the range. Even the long-legged P-51 Mustangs strained to make such flights. Japanese air defense commanders, studying captured American intelligence documents and monitoring radio traffic, had concluded that enemy fighters based in the Ryukyus could not reach central Honshu. Their defensive deployments reflected this belief. They were about to discover they had miscalculated catastrophically. The P-47 Newtons represented the final evolution of Republic Aviation's Thunderbolt design, a radical departure created specifically for the vast distances of the Pacific War. While earlier Thunderbolts had earned fearsome reputations over Europe as high-altitude escorts and ground attack aircraft, they suffered from limited range that made them unsuitable for the immense oceanic expanses separating American island bases from Japanese targets. The P-47D, the most common variant, carried 370 gallons of internal fuel. With drop tanks, its maximum combat radius reached approximately 450 miles. Useful for supporting operations around the Philippines or covering B-29 raids from Saipan to nearby islands, but insufficient for strikes against the Japanese home islands from newly captured bases. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Republic Aviation's solution emerged from a complete wing redesign. Engineers extended the wingspan by 1 foot, squared off the wingtips, and most critically, integrated fuel tanks directly into the wing structure. Each wing housed multiple bladder cells holding 100 gallons of fuel. Combined with enlarged fuselage tanks, the P-47 Newtons carried 556 gallons internally, 50% more than the P-47D. With 4 external drop tanks, 2 under the wings and 2 under the fuselage, total fuel capacity reached 1,266 gallons. The numbers translated to range figures that seemed impossible for a single-engine fighter: 2,200 miles with external tanks, combat radius exceeding 1,000 miles, but numbers on paper meant nothing without proof in combat. The 318th Fighter Group had received their first P-47Ns in April 1945, becoming the first operational unit to fly the type in combat. They had tested the aircraft on missions to Kyushu, to Korea, striking Japanese airfields and infrastructure. The P-47 Newtons performed as promised. Pilots marveled at flying 4-hour missions without fuel anxiety, at cruising over vast stretches of ocean with fuel gauges showing comfortable reserves. The heavy fighter, weighing nearly 20,000 pounds at takeoff, proved remarkably docile despite its bulk. An autopilot system allowed pilots to rest during the long overwater legs. Armrests reduced fatigue. Every detail reflected lessons learned from earlier Pacific operations where pilot exhaustion degraded combat effectiveness as much as enemy action. Japanese intelligence services monitored American air operations closely. Radio intercept stations throughout the home islands tracked bomber formations, providing advance warning of raids. Shore-based radar installations detected incoming aircraft up to 150 miles offshore, though coverage remained spotty. Intelligence analysts studied American aircraft capabilities methodically, compiling detailed assessments of range, performance, and operational patterns. Their reports on the P-47 Thunderbolt, based largely on encounters with earlier variants in the Philippines and Southwest Pacific, emphasized its limited range and unsuitability for long-distance operations. Japanese defensive planning assumed American fighters based in Okinawa and the Ryukyus could threaten only southern Kyushu and perhaps Shikoku, not central Honshu or the Tokyo region. This assumption shaped force dispositions throughout the home islands. Fighter units defending the capital region operated under the belief that American escort fighters could not accompany bombers to Tokyo from Ryukyu bases. The strategic situation facing Japan in spring 1945 had deteriorated beyond recovery, though the government refused to acknowledge the inevitable. Okinawa, the gateway to the home islands, fell to American forces after 3 months of brutal combat that cost the Imperial Japanese Army over 100,000 dead. The island's capture placed American air power within easy striking distance of Kyushu and positioned invasion forces for the final assault on the Japanese archipelago. Operation Ketsu-go, the defense plan for the home islands, called for concentration of all remaining military forces to repel the expected invasion. But before invasion came bombardment. Boeing B-29 superfortresses, flying from bases in the Marianas and later Okinawa, systematically destroyed Japanese cities with incendiary raids that killed hundreds of thousands of civilians and obliterated industrial capacity. The raids followed a deliberate pattern established by General Curtis LeMay, commanding 21st Bomber Command. Initial high-altitude precision bombing attempts in late 1944 achieved limited results. Japanese fighters and anti-aircraft guns, though declining in effectiveness, still inflicted losses. Winter weather obscured targets. Bombs scattered across wide areas, missing intended factories and rail yards. LeMay responded by switching to night incendiary raids flown at low altitude. Bombers stripped of guns to increase bomb loads burned entire cities in single raids. Tokyo, Yokohama, Osaka, Nagoya, Kobe, one by one, Japan's urban centers transformed into seas of ash. Japanese air defenses struggled to counter the onslaught. By April 1945, fuel shortages grounded much of the remaining fighter force, husbanding aircraft and pilots for the invasion defense. What fighters did sortie found American bomber streams, increasingly accompanied by long-range P-51 Mustang escorts flying from Iwo Jima. The Mustang's arrival over Japan changed the air war decisively. Japanese pilots, many with minimal training and flying obsolescent aircraft, faced American fighters that matched or exceeded their performance while operating hundreds of miles from base. Attrition mounted catastrophically. The Imperial Japanese Army Air Force and Imperial Japanese Navy Air Force lost pilots faster than training programs could replace them. By spring 1945, average pilot experience had fallen below 50 hours of flight time. Yet, Japanese intelligence assessments continued to draw distinctions between different American fighter types and their capabilities. The P-51 Mustang, with its liquid-cooled Packard Merlin engine and sleek airframe, could reach Tokyo from Iwo Jima, this fact Japanese planners acknowledged and planned for. The P-38, Lightning, with twin engines and drop tanks, possessed similar range, but the P-47 Thunderbolt, the massive radial-engined fighter that had dominated skies over Europe, remained categorized as a short-range tactical fighter, unsuitable for strategic escort missions over Japan. Intelligence reports from the Philippines campaign painted the Thunderbolt as a capable ground attack aircraft and competent dogfighter at medium to high altitudes, but one limited by fuel capacity to operations within 400 to 500 miles of base. This assessment made perfect sense based on available data. The P-47D, the variant that equipped most American fighter groups in 1944, did indeed have limited range compared to the Mustang. Pilots transitioning from P-38 seconds and P-40 seconds to Thunderbolts in the Pacific complained about the aircraft's short legs. The 348th Fighter Group in the Philippines operated P-47Ds for much of 1944, before converting to P-51 commanders would know when escorts could and could not accompany American strikes. The presence or absence of escort fighters determined defensive tactics. Bombers without escorts could be attacked throughout their approach and over target. Formations with escorts required different tactics, engaging the fighters to draw them away from bombers, accepting losses to create openings for attacks on the bombing aircraft. Japanese intelligence estimated P-51 Mustang escort radius from Iwo Jima at approximately 650 miles, sufficient to reach Tokyo, but leaving little fuel for extended combat. P-47 Thunderbolts, based on performance data from earlier variants, could not reach the capital region from any American base. Therefore, fighters launching from Shima or other Ryukyu airfields posed threats only to southern Kyushu and perhaps Shikoku. Central Honshu remained beyond their reach. This calculation directly influenced the distribution of Japan's dwindling fighter strength. Units in Kyushu faced the immediate threat of invasion and received priority for fuel and replacement aircraft. Fighters defending Tokyo and central Honshu could be held back, preserving strength for the final decisive battle. Every gallon of aviation fuel, every replacement pilot, every spare part had to be allocated according to assessed threat levels. Wasting resources defending against attacks that could not occur would be criminally negligent. Japanese planners, therefore, positioned their forces according to their understanding of American fighter capabilities. American strategic planning, meanwhile, proceeded along different lines. The capture of Okinawa and establishment of airfields on Shima, a small island just off Okinawa's northwest coast, created opportunities for forward deployment of fighter groups that could strike throughout the Japanese home islands. The 318th Fighter Group moved to Shima in late April 1945, joining other air units preparing for intensified operations against Japan. Their P-47Ns could reach any target in Kyushu easily, but the question remained whether they could hit more distant objectives: Shikoku, western Honshu, perhaps even Tokyo itself. Mission planners studied the numbers carefully. Shima to Tokyo measured approximately 840 miles direct distance, round trip 1,680 miles. The P-47 Newtons' maximum range with full external fuel load reached 2,200 miles under optimal conditions. But optimal conditions meant cruising at economical speeds with no combat maneuvering, no diversions, no reserve for contingencies. Combat operations required fuel for takeoff, climb to altitude, cruise out, combat over target, cruise back, descent, and landing with safe reserves. Weather might force diversions. Combat might require full throttle settings that consumed fuel at dramatically higher rates. Pilots might need to jettison external tanks if attacked during approach. The mission would push the P-47 Newtons to its absolute limits, but it could be done. American commanders decided to prove it. The 318th Fighter Group received orders for a maximum range strike against Tokyo, scheduled for August 13, 1945. The mission would serve multiple purposes. It would demonstrate American fighter range to Japanese defenders. It would provide combat experience for pilots in very long-range operations. It would strike military targets in the capital region. And it would deliver a psychological message nowhere in Japan lay beyond American reach. Every city, every military installation, every factory could be hit by fighters that possessed the endurance to escort bombers throughout their missions and the performance to dominate Japanese interceptors in combat. The Japanese, unaware of the P-47 Newtons' capabilities, continued operating under their established assumptions about American fighter range. Intelligence reports noted the appearance of a new Thunderbolt variant in the Pacific, but lacked detailed performance specifications. No one in Japanese defensive commands suspected that American single-engine fighters could soon appear over Tokyo, launched from bases nearly 900 miles distant. The P-47 Newtons, Thunderbolt that Lieutenant Colonel Sanders would fly to Tokyo on August 13th, represented the culmination of 4 years of continuous refinement to Republic Aviation's original design. The aircraft, serial number 4-88406, carried modifications that distinguished it from every previous Thunderbolt variant. The wing, 42 feet 7 inches from tip to tip, contained 8 separate fuel cells integrated into the structure. 4 cells in each wing root, positioned between the main spars, held 25 gallons each. The engineering required to make this work had consumed months of development time. Fuel cells had to fit within the wing profile, without compromising structural strength. Plumbing had to route fuel from wing tanks to the main system without creating potential failure points. The wet wing added weight nearly 400 pounds empty, over 1,200 pounds when full, requiring strengthened landing gear and revised weight and balance calculations. The fuselage held 2 self-sealing fuel tanks. The main tank, mounted behind the firewall separating engine from cockpit, contained 270 gallons. An auxiliary tank beneath the pilot's seat held 100 gallons. Both tanks featured thick rubber construction with multiple layers that would swell when punctured by bullets or shell fragments, sealing small holes automatically. This self-sealing technology, developed early in the war, had saved countless pilots from death by fire, but it added weight and reduced usable fuel volume. Every gallon counted on a mission to Tokyo. External fuel storage provided the final element of the P-47N's extended range. 4 drop tanks hung from hard points under wings and fuselage. The standard configuration used 2 165-gallon tanks under the wings and 2 175-gallon tanks under the belly, though various combinations were possible depending on mission requirements. These tanks, constructed of pressed metal or paper-impregnated composite, were designed to be jettisoned when empty or when combat required. Releasing external tanks reduced drag and weight, improving maneuverability and speed. But it also meant the fuel they contained had to be consumed before reaching hostile airspace. Mission planning required careful calculation of when to drop tanks, balancing fuel reserve needs against combat performance requirements. The Pratt & Whitney R2-80077 engine driving the P-47N produced 2,800 horsepower at war emergency power with water methanol injection. This represented a 30% increase over the R2-80021 that powered early P-47Ds. The engine, an 18-cylinder 2-row radial design, weighed over 2,000 pounds and measured 52 inches in diameter. Its bulk gave the Thunderbolt its distinctive blunt-nosed profile, but that bulk delivered reliability and power at high altitude where thin air defeated most engines. A 2-stage supercharger, driven by exhaust gases channeled through a turbine in the rear fuselage, compressed intake air to sea level density even at 30,000 feet. This gave the P-47N's performance advantages at altitude that Japanese fighters, lacking equivalent supercharging, could not match. Fuel consumption varied dramatically based on power settings. At economical cruise, approximately 220 miles per hour at 10,000 feet, with the engine turning 1,800 RPM and producing roughly 40% power. The R2800 burned approximately 100 gallons per hour. At this setting, the P-47N's internal fuel provided 5.5 hours of flight time. Adding external tanks extended this to over 9 hours. But combat power settings consumed fuel catastrophically faster. War emergency power, using water methanol injection to prevent detonation, burned nearly 300 gallons per hour. Even brief periods at full power could drain fuel reserves that represented hours of economical cruise. Mission planners for the Tokyo strike calculated fuel requirements meticulously. Takeoff and climb to cruise altitude would consume approximately 100 gallons. Cruise to the Japanese coast at economical settings would burn another 300 gallons over 3 hours. Approaching hostile airspace, pilots would switch from external to internal fuel and prepare to jettison drop tanks. The external tanks would provide 710 gallons, enough for the outbound leg with reserves. Internal fuel, 556 gallons, would power the fighter over Japan, through combat if necessary, and home to Shima. Reserve fuel, approximately 100 gallons, provided margin for weather diversions or extended combat. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The crews preparing aircraft for the mission worked through the night of August 12th. Each P-47 newtons required careful inspection. Engine oil levels checked, hydraulic fluid topped off. Oxygen system tested. Pilots would fly at altitudes requiring supplemental oxygen for hours. Radio equipment verified. The 850 caliber machine guns, 4 in each wing, had to be loaded with full ammunition belts. Each gun carried 500 rounds, 3,200 rounds total, weighing over 800 pounds. On a maximum range mission, some pilots might choose to reduce ammunition load to save weight, but for a strike on Tokyo, full combat load was mandatory. Armourers fueled each aircraft carefully, monitoring flow rates to ensure tanks filled completely without overflow. Aviation gasoline, 130 octane rating, had to be pumped into fuselage tanks first, then wing tanks, then external tanks. The sequence mattered because fuel system checks required specific procedures. Ground crews used dipsticks to verify fuel levels, comparing readings against capacity charts. A single gallon short in any tank might mean the difference between reaching base or ditching in the ocean 50 miles offshore. Dawn on August 13, 1945, broke clear over Shima. The weather forecast predicted good visibility along the route to Tokyo, with scattered clouds at medium altitude. Surface winds remained light. Conditions were as favorable as could be expected. At 0600 hours, pilots assembled for final briefing. Colonel Sanders reviewed the flight plan. Take off at 0700, climb to 10,000 feet. Form up and proceed north-northwest at indicated airspeed of 220 miles per hour. Cross the Japanese coast south of Kagoshima. Continue north up the length of Kyushu, then across the inland sea and over western Honshu. Approach Tokyo from the west. Expected time over target, 1100 hours. 4 hours outbound. Strike targets of opportunity around Tokyo airfields, rail yards, industrial facilities. Departure by 1200 hours. Return flight 4 hours. Expected landing at Shima, 1630 hours. Total mission time, 9.5 hours. Pilots checked their equipment. May West life preservers. Survival kits containing emergency rations, first aid supplies, signal flares, and a Gibson Girl emergency radio transmitter. Shoulder holsters with Colt .45 pistols. Maps printed on silk that could be concealed if shot down. The precautions reflected the reality that ditching in the ocean or forced landing in Japan meant probable death. The vast Pacific offered few opportunities for rescue. Japanese treatment of downed airmen, particularly near war's end, often meant immediate execution. At 0650, engines began starting. The R-2000-800's distinctive sound, a deep, powerful rumble, echoed across the airfield as 54 fighters came to life. Propellers turned, slowly at first, then accelerating to blur as engines reached idle RPM. Blue smoke from oil burning in cylinders drifted across the flight line. Pilots ran through cockpit checks methodically. Magnetos check, oil pressure check, fuel pressure check, hydraulics check, oxygen flow check, radio check, gun switches safe, mixture rich, propeller full increase, throttle 1 inch. Every item on the checklist completed, verified, completed again. At 0700 precisely, Colonel Sanders released brakes and advanced throttle. His P-47 newtons, heavy with fuel, accelerated slowly down the runway. Tail came up at 60 miles per hour. At 105 miles per hour, the fighter lifted off, climbing gradually. One by one, the other 53 aircraft followed. The formation assembled over Shima, circling while late aircraft joined up. By 0730, all 54 Thunderbolts had formed into 4-ship flights. Sanders waggled his wings and turned north. The formation followed. The flight to the Japanese coast passed uneventfully. Pilots settled into the monotony of long-range cruise, monitoring engine instruments, watching fuel gauges, scanning the horizon. The autopilot system allowed brief respites from holding the control stick. Every 30 minutes, pilots switched fuel tanks according to procedure. Burn from external tanks first, preserving internal fuel for combat and return. The formation maintained radio silence, communicating through wing movements and hand signals. At 10 to 100 hours, the mountains of southern Kyushu appeared on the horizon. Sanders checked his fuel gauges. External tanks nearly empty, internal tanks full, right on schedule. He switched to internal fuel and prepared to jettison externals. At the coast, he toggled the release. 8 external tanks tumbled away from his aircraft, light enough now that they fluttered like leaves. Behind him, 53 more fighters shed their tanks. 216 metal cylinders fell into the East China Sea. The formation crossed the coast at 10,000 feet, expecting immediate interception. Japanese radar surely had tracked them. Fighters should be climbing to engage. But the sky remained empty. Sanders led his formation north, climbing to 15,000 feet over Kyushu. Still no opposition. The Thunderbolts droned northward, 800 horsepower engines pulling them steadily toward Tokyo. Over the inland sea, scattered clouds provided momentary concealment, but no Japanese fighters appeared. At 1100 hours, Tokyo came into view. The city sprawled below, partially obscured by haze and smoke from previous raids. Sanders selected a rail yard on the western outskirts as his target. He rolled into a dive, accelerating to 350 miles per hour, and pressed the trigger. 8 50-caliber machine guns hammered, tracers arcing down into rail cars and buildings. He pulled up, circled, dove again. Other flights attacked airfields, warehouses, bridges. For 30 minutes, the Thunderbolts ranged over Tokyo unopposed. Japanese air defense commanders, monitoring radar reports of the incoming formation, had calculated that these aircraft must be B-29 seconds, or perhaps carrier-based fighters. Single-engine fighters based in Okinawa could not reach Tokyo. The reports had to be wrong, or the aircraft were Navy fighters from carriers offshore. When the formation actually appeared over the capital, defensive response scrambled chaotically. Fighters launched from nearby bases, but by the time they reached altitude, the American formation was departing, heading south at high speed. The return flight tested pilot endurance more than the outbound leg. Adrenaline from combat faded, leaving exhaustion. 4 hours remained to Shima. Fuel gauges showed adequate reserves, but the Pacific stretched endlessly below, blue and empty. Every pilot understood that engine failure now meant ditching with little hope of rescue. They maintained formation, maintained altitude, maintained radio silence. The only communication came through occasional wing rocks as flight leaders checked on their wingmen. Japanese defensive commanders struggled to comprehend what had occurred. American single-engine fighters had struck Tokyo from Okinawa. The raid lasted 30 minutes. No bombers accompanied them. They arrived, attacked, and departed before effective interception could be mounted. Post-mission analysis revealed the attackers were P-47 Thunderbolts, not P-51 Mustangs or carrier aircraft. Intelligence officers reviewed their assessments of American fighter capabilities. Every previous estimate of P-47 range had proven catastrophically incorrect. If Thunderbolts could reach Tokyo from Okinawa, then no location in Japan lay beyond American fighter range. Every city, every airfield, every military installation could now be hit by escorts accompanying bomber formations or by pure fighter sweeps. The defensive calculations that had shaped force disposition throughout the home islands were based on false premises. At 16:20 hours, Shima appeared ahead. Sanders descended to traffic pattern altitude, extended landing gear, and touched down. His P-47 Newtons rolled to a stop with fuel gauges showing approximately 70 gallons remaining, enough for another 30 minutes of flight. One by one, the other fighters landed. 54 had departed. 54 returned. Not a single aircraft had been lost to enemy action. One pilot reported his engine running rough on the return leg, but he had made it home. Ground crews swarmed over the fighters, refueling, inspecting, preparing them for the next mission. The mission report filed by Colonel Sanders noted the round-trip distance as 1,680 statute miles. Flight time, 9 hours and 30 minutes. Fuel consumption matched predictions almost exactly. The P-47 Newtons had performed flawlessly at the extreme limit of its operational radius. More importantly, the mission demonstrated that American fighters could now operate over any target in Japan with impunity. The psychological impact on Japanese commanders exceeded the physical damage inflicted. If fighters could reach Tokyo, then the anticipated invasion would proceed under American air supremacy more complete than anything seen previously in the war. Japanese intelligence services updated their assessments immediately. New reports on American aircraft capabilities circulated through military commands. The P-47 Newtons Thunderbolt, previously dismissed as a short-range tactical fighter, now appeared in intelligence summaries as a strategic threat. Estimated maximum range, 2,000 miles. Combat radius, over 1,000 miles. Performance at altitude superior to most Japanese fighters. Armed with 8 heavy machine guns and capable of carrying bombs or rockets. More importantly, available in large numbers and deployed to bases throughout the Ryukyus. Japanese defensive planners scrambled to revise force dispositions, but the reality was that no adjustment could compensate for the fundamental miscalculation of American capabilities. The 318th Fighter Group flew additional long-range missions over the following days. On August 14th, they struck targets in central Honshu. On August 15th, they were preparing for another Tokyo strike when orders came through cancelling the mission. Japan had surrendered. The war ended before the P-47 Newtons could fully demonstrate its capabilities in sustained combat operations. But the August 13th mission had proven the critical point. American single-engine fighters could strike anywhere in Japan. The defensive assumptions that had shaped Japanese planning for the final battle were wrong. The aircraft they had believed incapable of reaching the home islands from distant bases had appeared over Tokyo, attacked, and returned safely. The P-47 Newtons would remain in service for several years after the war, eventually being redesignated F-47 Newtons in 1948. Air National Guard units flew the type until 1955, but its moment of strategic significance came during those final weeks of the war when it demonstrated capabilities that Japanese intelligence had deemed impossible. 1,680 miles from Shima to Tokyo and back, 9.5 hours in the cockpit of a single-engine fighter. Every assumption about fighter range and capability overturned by a single mission that proved what theoretically possible had become operationally routine. The intelligence failure that allowed 54 P-47 Newtons, Thunderbolts, to strike Tokyo unopposed represented more than a simple miscalculation of aircraft specifications. It exposed a systemic breakdown in Japanese strategic assessment that had plagued defensive planning throughout the final year of the Pacific War. In the weeks following the April 13th raid, Japanese military intelligence scrambled to understand how their carefully compiled assessments of American fighter capabilities had proven so catastrophically wrong. The April 13th mission accelerated planning for kamikaze operations against the expected invasion fleet. If conventional fighter defense could not protect the home islands from American air attacks, then suicide attacks offered the only remaining option for inflicting losses that might force negotiated settlement rather than total defeat. Japanese commanders diverted resources toward training kamikaze pilots and stockpiling aircraft for one-way missions. The P-47 Newtons raid over Tokyo demonstrated that conventional air combat had become hopeless. Desperate measures replaced rational military planning. American intelligence officers, monitoring Japanese communications through signals intercept and code breaking, detected the shift in Japanese defensive posture following the raid. Radio traffic increased as Japanese commands scrambled to reposition forces and revise operational plans. Intercepted messages referenced the April 13th attack specifically, with senior officers demanding explanations for how American fighters had reached Tokyo undetected and unopposed. The intelligence windfall provided American planners with valuable insights into Japanese defensive preparations, confirming that the psychological impact of the raid had achieved strategic effects disproportionate to the bombs and bullets expended. For the pilots of the 318th Fighter Group, The Tokyo mission became a defining moment in their operational history. They had proven their aircraft could perform as promised at the absolute limit of its design specifications. More importantly, they had demonstrated that American air power had achieved such technological and numerical superiority that even the enemy's capital city lay open to attack. In subsequent missions, pilots flew with confidence born from that first Tokyo strike. They knew Japanese fighters lacked the fuel, pilots, and aircraft to mount effective opposition. They knew their P-47Ns possessed the range to reach any target and return safely. The psychological advantage this confidence provided translated into aggressive tactics that maximized the impact of every mission. The raid also influenced American planning for the final assault on Japan. Military commanders recognized that air supremacy was now so complete that close air support for invasion forces could be maintained continuously. Ground troops advancing into Japan would operate under an umbrella of fighter cover, unlike anything seen in previous amphibious operations. This air superiority promised to reduce casualties among invasion forces by suppressing Japanese defensive positions before infantry encountered them. The strategic calculations that would shape Operation Downfall, the planned invasion of Japan, incorporated lessons from the April 13th mission. When Emperor Hirohito announced Japan's surrender on August 15, 1945, the P-47N Thunderbolt had been operational for less than 5 months. In that brief window, the aircraft had fundamentally altered the strategic equation in the Pacific War. The Tokyo raid stood as proof that American industrial capacity had produced not merely larger numbers of aircraft, but qualitatively superior designs that rendered Japanese defensive planning obsolete. Yet the P-47N's significance extends beyond its immediate tactical success to what it represented about the nature of warfare in the final year of World War II. The aircraft embodied American engineering philosophy at its apex, where Japanese designers sought to maximize performance through lightweight construction and minimal fuel capacity. American engineers accepted weight penalties to achieve strategic range. The P-47N weighed nearly twice as much as a Japanese Zero fighter, but it could fly missions the Zero could not conceive. This design philosophy reflected broader differences in how the two nations approached the Pacific War. Japan optimized for initial tactical advantage, creating fighters that excelled in close combat but lacked range and durability. America optimized for strategic reach, building aircraft that could project power across vast distances while protecting pilots with armor and redundant systems. By 1945, the American approach had proven decisively superior. The intelligence failure that made the Tokyo raid possible offers lessons that remain relevant to military planning today. Japanese commanders possessed adequate information about earlier Thunderbolt variants, but they failed to anticipate that American engineers would fundamentally redesign the aircraft to meet Pacific War requirements. This failure reflected a common pattern in intelligence assessment. Adversaries are assumed to be constrained by the same limitations that restrict your own capabilities. Japanese planners knew their own aviation industry struggled to produce long-range fighters due to material shortages and manufacturing limitations. They projected these constraints onto American industry, failing to comprehend the scale of American industrial mobilization. When P-47N Thunderbolts appeared over Tokyo, they shattered assumptions that had seemed reasonable based on incomplete information. The P-47N's post-war service proved brief. Air National Guard units flew the type into the early 1950s, but jet aircraft rapidly made piston-engine fighters obsolete. By the time the Korean War began, P-47Ns sat in storage yards, replaced by F-80 Shooting Stars and F-86 Sabres. Yet the engineering innovations that made the P-47N possible influenced subsequent fighter designs. The concept of integral fuel tanks within wing structures became standard practice. The emphasis on pilot comfort and automation systems during long missions informed cockpit design in later aircraft. The lessons learned about extending single-engine fighter range shaped development of early jet fighters, which faced similar challenges balancing performance with endurance. For the pilots who flew the Tokyo mission, the memory remained vivid decades later. Veterans recalled the weight of the fuel-laden aircraft on takeoff, the monotony of hours over empty ocean, the sudden rush of adrenaline when Tokyo appeared through the haze. They remembered the strange emptiness of the sky over Japan's capital, the absence of expected opposition, the creeping realization that they were witnessing the complete collapse of enemy air defense. Some veterans visited Japan years later, standing in the rebuilt Tokyo and trying to reconcile the modern city with the smoke-shrouded target they had attacked in 1945. The April 13th mission answered a question that had seemed theoretical when Republic Aviation began designing the P-47 Newtons. Could a single-engine fighter strike targets 800 miles from base and return safely? The answer was yes, and in proving it possible, those 54 Thunderbolts demonstrated that American air power had achieved capabilities that rendered traditional concepts of defensive perimeters meaningless. No fortress remained impregnable when fighters could range anywhere at will. That lesson, learned over Tokyo in the final months of World War II, shaped air combat doctrine for generations to come. The war ended 4 months after those P-47Ns proved Japanese intelligence wrong. 1,680 miles from Shima to Tokyo and back, 9.5 hours that changed everything. 54 aircraft departed, 54 returned, and Japan never knew American fighters could reach that far until they were already overhead, making the impossible look routine. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.